In this video, we'll look at inequalities that involve absolute value. We'll look at 3 examples. In the first example here, we'll consider what happens when an absolute value is less than a number. Following that, we'll look at the cases in which the absolute value is greater than a number and when the absolute value falls between 2 numbers. So let's start with example number 1. We are trying to find the values of x such that 2x minus 5's absolute value is less than 17. Let's recall what absolute value means. When we talk about absolute value, we are talking about distance from 0. So if we have the absolute value of x, we're talking about x's distance from 0. So let's scale this down to a more basic example. If we had the absolute value of x less than 4, for example, we are trying to find the values of x whose distance from 0 is less than 4. So how could that happen? Let's take a look at the number line. Here's 0, and if we want numbers whose distance from 0 is less than 4, well, I guess we could have values that actually fall between 0 and 4. Now we wouldn't include 4 because it's strictly less than 4 here. But don't forget, we also have the case where the numbers fall between -4 and 0. If you think about these numbers, their distance from 0 is also less than 4. Looking at our number line here, we see that if we want the absolute value of x to be less than 4, that is, if we want x's distance from 0 to be less than 4, we can choose any x values between -4 and 4. Now the same idea applies to our example here in example number 1, except we're not talking about x's distance from 0 because we're not talking about the absolute value of x. We're talking about the absolute value of 2x minus 5. So if 2x minus 5's absolute value is supposed to be less than 17, what that means is 2x minus 5's distance from 0 has to be less than 17. So again, take a quick look at a number line here. If the distance from 0 is going to be less than 17, that means we could have values between 0 and 17, not including 17 in this case, but we could also have values between -17 and 0. So that is, any value between -17 and 17 would give us an absolute value that's less than 17 because the distance from 0 is less than 17. And again, we're not talking about x's absolute value here. We're talking about 2x minus 5's absolute value. So that is, 2x minus 5's distance from 0 has to be less than 17. And what that means is 2x minus 5 has to work out to something between -17 and 17. Now this just looks like a regular linear inequality, so we can go ahead and solve it by isolating x in the middle. We'll do so by adding 5 to each piece. So that gives us -12, which is less than 2x, which is less than 22. And we'll divide everything by 2, which gives us -6, which is less than x, which is less than 11. And that's our answer. Our x values must be between -6 and 11 if we want 2x minus 5's absolute value to be less than 17. If we wanted to show this solution on a number line, we'd simply say, here's 0, 11 is up here, -6 is down here, and we are considering all the values between -6 and 11, not including them because the original question was strictly less than 17. And that's it. Let's move on to example number 2. In this example, we have the absolute value of 3x plus 8 being greater than 20, and we're supposed to find all of the x values that make this happen. Okay, let's go back and take a look at this in a more basic way. Again, if we're talking about the absolute value of x, we are talking about x's distance from 0. Say the absolute value of x was to be greater than 4. How could that happen? Well, it just means the number's distance from 0 has to be greater than 4. So we could have actual values that are greater than 4. For example, those. But the distance from 0 being greater than 4 also gives us the possibility of the numbers being smaller than negative 4, because if you think about these numbers in this area, their distance from 0 is also greater than 4. Now we could have either of these two cases. That is, if we want the absolute value to be greater than 4, that means the distance from 0 has to be greater than 4, and this can happen in two ways. So we could have x values that are less than negative 4, or we could have x values that are greater than 4, and both cases would be acceptable. So in our example here, we're talking about the absolute value of 3x plus 8 being greater than 20. That means 3x plus 8's distance from 0 has to be greater than 20. So quick number line sketch. If the distance from 0 has to be greater than 20, that means we could have values that are actually greater than 20, or we could also have values that are less than negative 20. In both of these cases, the distance from 0 is greater than 20. So writing this out in two separate cases, we have 3x plus 8 could be something less than negative 20, or 3x plus 8 could be something greater than 20. And either of these cases would make 3x plus 8's distance from 0 greater than 20. So we'll solve each one separately. The first one, 3x plus 8 is less than negative 20, would mean that 3x is less than negative 28. And that would mean x is less than negative 28 divided by 3, or negative 28 thirds. And we can leave that as a fraction. There's nothing wrong with that. The other option is that 3x plus 8 works out to a number greater than 20. Let's solve this for x. We'd have 3x is greater than 12, subtracting 8 here, and dividing by 3 gives us x is greater than 4. So if we want the absolute value of 3x plus 8 to be greater than 20, that is, the distance from 0 of 3x plus 8 to be greater than 20, we have two options. Either x is less than negative 28 thirds, or x is greater than 4. And both of these possibilities would satisfy the original equation. If we wanted to show this on the number line, here is 0. We could have negative 28 thirds down here, just a little bit more negative than negative 9, negative 28 thirds. And we could have 4 right here. And we are simply considering the possibility of having x values that are lower than negative 28 thirds, or x values that are higher than 4. And either or are acceptable. So in this question, the actual final answer is, therefore, x is less than negative 28 thirds, or x is greater than 4. Let's move on to example number 3, the final example. In this case, we have 4x minus 5's absolute value having to be between 7 and 23. So what this means is 4x minus 5's distance from 0 has to land between 7 and 23. Let's look at the basic idea here. Absolute value of x refers to x's distance from 0. If we wanted that to fall between two numbers, for simplicity, let's just say between 3 and 5. How could this happen? How could the distance from 0 fall between 3 and 5? Well, I guess we could actually have numbers between 3 and 5. In that case, the distance from 0 is certainly between 3 and 5. But we could also have numbers that fall between negative 3 and negative 5. Because when you think about that, even though these numbers are negative, their distance from 0 still falls between 3 and 5. And you could have either of these cases. That is, you could have x values between negative 5 and negative 3, or you could have x values between 3 and 5. So in our example, we're talking about 4x minus 5's absolute value falling between 7 and 23. So again, that means 4x minus 5's distance from 0 has to be between 7 and 23. And that can happen two different ways. you could actually have numbers between 7 and 23. I'm using open circles here because we're not including 7 and 23. If we were including 7 and 23, you would just have filled in circles there. And we also have the possibility of numbers between negative 23 and negative 7, because in that case, the distance from 0 is still between 7 and 23. And you can have either case, so let's write them out separately. We could either have 4x minus 5 falling between negative 23 and negative 7, or we could have 4x minus 5 falling between 7 and 23. And we'll solve each one separately, just like we did in the last example. So on the left here, 4x minus 5 is between negative 23 and negative 7. We'll add 5 to all sides of this, leaving us with negative 18 is less than 4x, which is less than negative 2. And dividing by 4, we get negative 18 over 4 is less than x, which is less than negative 2 over 4. And we can reduce these fractions, the first one being negative 9/2, and the second one being negative 1/2. And if you feel like it, you could write negative 9/2 as negative 4.5, and negative 1/2 as 0.5, negative 0.5. On the right side, we have 4x minus 5 is between 7 and 23. So we'll just go ahead and solve that to isolate x in the middle. Adding 5 to each piece, we get 12 is less than 4x, is less than 28. And dividing by 4, we get 3 is less than x, is less than 7. So here we go. We can either have x values between negative 9/2 and negative 1/2, or we can have x values between 3 and 7. And you can have either of these cases. You do not need to have them simultaneously. As you can see, that would be impossible to have a number between negative 9/2 and negative 1/2 as well as between 3 and 7. There are no numbers that satisfy both of them. But we don't need that. We just need one or the other, and it will satisfy this equation. If you wanted to show that on a number line, 3 to 7 is one option. So we could draw that right here. Again, we're not including 3 and 7, so we'll use open circles. But if the original less than signs were less than or equal to signs up here, then of course you would include those values, and you'd be using less than or equal to signs through the whole problem, including in the final answer. Getting back to the number line here, we also have the option of numbers between negative 1/2 and negative 9/2. Okay, so that would look like this. All right, and you can have either or. So to state your final answer for this question, we would say, therefore, the x value has to land between negative 9/2 and negative 1/2, or x could be between 3 and 7. And that's the final answer.